Okay, now let's have a look at a geometric series. Once again, I'm going to keep hammering on about this. Geometric means we are multiplying by, now we know, an r every time in a sequence. Series means we are adding all of the terms in that sequence. And we're going to very quickly prove what the sum of all of the values in a geometric sequence is. Now, similarly to when we did this with the arithmetic sequence, there are a couple of tricks to it that might not intuitively make sense, but we do need to know them. So I'm going to start off, same as last time, by defining n specifically, as a sum of all items in my geometric sequence up until the nth term. So, what's the first term in my geometric sequence? Well, it is a. Second term will be a times r. Third term, a times r squared, and so on until I get to a times silly mistake, I will just keep that in. AR to the n minus 2 plus AR to the n minus 1, and we will end there. Remember, we never go up to AR to the n because then that will exceed what we're looking at, which we showed in the last video. So I've got this summation. It's all of them added together. Now, if you remember with the arithmetic sequence and the arithmetic series proof, we then rewrote them backwards, right? And then we added them from there and we did some nifty stuff, but we're not going to do that here. Here, the trick is we're going to multiply this entire sequence by r. So I'm going to have r times by s. So let's see how quickly I can switch these pens. I'm not quite the other guy on YouTube, but yeah. So my a is going to be multiplied by r plus a r squared now plus a r cubed. How does he do it? He switches them very quickly. I don't know. All the way up to ar to the n minus 1 plus ar to the n. And in this case, I do have an ar to the n because I'm multiplying everything by r. So when I multiply this last term here by r, well, if you want a quick proof, ar to the n minus 1 times r, I'm combining the powers, that's r to the 1, ar to the n minus 1 plus 1, minus 1 plus 1 cancels, and I end up with ar to the n. So now I've multiplied through by r, I do end up with just a power of n. Now what I'm going to do is I'm going to take them away from one another. You'll see why in a second. I'm going to do Sn minus Rsn. So let's see what happens when I do that. Well, I'm going to skip this a for now. I'm going to see that I've got an AR here and an AR here. So if I minus them, they're going to cancel. I've got an AR squared here and an AR squared here, and they're going to cancel. And this is quite often what we generally do with tricks in maths, especially with series like this. We always want to get to a point that we're cancelling a load of the nonsense and just being left with some key bits. Okay, now I haven't got it written here, but there's a secret AR cubed in the middle of all that. There's also a secret AR n to the minus 1 somewhere in here. I've got my AR to the n minus 1 here, my AR to the n minus 1 here, and I don't have an AR to the n in this series. So from this series, I'm left with an A. And from this series, I'm left with an AR to the n. It's a minus because I'm doing that minus that. So that minus that, and I'm left with this. Now I can do some factorizing. Remember, I want s to the n on its own. So Sn equals, factored out of 1 minus r equals, and I'm going to factor out an a on this side as well, a 1 minus rn. And I've kind of already left the space here. You can probably see where this is going. To get Sn on its own, I want to divide both sides by 1 minus r, and I end up with Sn is equal to a 1 minus r to the n over 1 minus r. Now, very quick note, you may sometimes see this the other way round. You may sometimes see this as Rn minus 1 or r minus 1 in the denominator. In general, it doesn't really matter which one it is. It's just a case of a negative. Two numbers being subtracted from each other with a modulus around it, chapter 2, will always give you 7 minus 3 and 3 minus 7 will always give you the same value. So it's just a case of worrying about tricky negatives, but hopefully we'll recognize when to ignore those and why sometimes you might see some mark schemes flip these. It really just depends on our value of r.